What is the electromagnetic spectrum? Electromagnetic spectrum is a continuum of electromagnetic energy that travels in a speed of light in form of waves or sine waves. A continuum is an uninterrupted or continuous ordered of sequence. Examples of continuums are free-flowing rivers or motion of the sea waves. A photon is the smallest quantity of any type of electromagnetic energy, just as an atom is the smallest quantity of an element. A photon may be pictured as a bundle of energy, sometimes called a quantum, that travels through space at a speed of light approximately 300,000 km per second, or some references at velocity of light of 186,000 meters per second. Wave model of electromagnetic radiation. In late 19th century, James Clerk Maxwell formulated the classical theory of electromagnetic radiation. He showed that visible light has both electric and magnetic properties, and they are correlated. Sine wave model of electromagnetic energy describes variations in the electric and magnetic fields as the photon travels with velocity. The important properties of this model are frequency, which represented by F, and wavelength, which represented by Greek letter lambda. Frequency is the number of wavelengths that pass a point of observation per second. The rate of rise and fall is frequency. It is usually identified as cycle per second. The unit of measurement is the hertz. 1 hertz is equal to 1 cycle per second. The wavelength is the distance from one crest to another, from one valley to another, or from any point on the sine wave to the next corresponding point. Range is the area where energy loses its destination. Frequency and wavelength will determine the measurement of the different kinds of electromagnetic spectrum, and they are inversely related. Example: 2 examples of sine waves, sine wave A and sine wave B at the same time, which is 1 second. Sine wave A has a 1 wavelength and excess considered as a half. Sine wave A has an increased or longer distance of wavelength. It is stated that frequency is inversely related, so frequency decreases. Sine wave B has 3 wavelengths if you're going to count, and wavelength is the shorter than wavelength of sine wave A, so wavelength B is decreases, so the frequency is increases. If there is 3 wavelength or 3 cycle in 1 second, so you're going to divide, equals 3 hertz. It is considered and understood that electromagnetic spectrum energy, as the frequency increases, it is directly proportional to the energy of photon. There is a strong energy, but wavelength or distance is decreases or shortened. The 7 electromagnetic spectrum are: first, radio waves; second, microwave; third, infrared; fourth, visible light; fifth, ultraviolet; sixth, X-rays; and seventh, gamma rays.